Okay, so thank you very much for the possibility to talk about my research today. My name is Judith Michael. I'm postdoc at the chair for software engineering at RWTH Aachen University, where we're doing research in a lot of areas, all related to modeling in different application domains and the foundations of modeling. What I'm talking about today is the area of assistive services. Now, if we want to provide assistance, what does this mean? It means that we have to provide situational support for human behavior at a specific time where either the person needs it or the person asks for it. And for providing this support, we use information which is either previously stored, but also information which we have from real-time monitored structural context, as well as behavior data about a person and the behavior of this person. The application domains where we can use such assistance is very broad, from medicine to automotive domain to smart homes, ambient assisted living, where we can support the elderly, up to aviation. And a lot of the use cases we're working on are in production, as we are part of the German Cluster of Excellence Internet of Production and have a lot of chairs working in mechanical engineering on this domain. Now, if we want to start such an assistive service and provide it to users, how does the basic functionalities and principles look like that we have to cover? In a first step, we need to set up the context information, which we will need later on in such a system. We have to learn the behavior. This learning could be twofold. Either we really learn it from a human, or we already use behavior models where we have a description about how people are behaving. And then during runtime of such a system, we have to monitor the behavior of this person as well as the context information, and then use it based on the previous information that we have and the real-time monitored behavior and context information. We provide some support. Now, what are the challenges when we try to provide assistance? You know it from the application domains that I've been talking about. It might be very critical functionality that you have to support with such assistive systems. In some cases, also in dangerous environments, depending on the domain you're working on. We might have issues with safety or also privacy, because we're working with very private data of people and their own behavior and context information. And we have a very broad, heterogeneous user group. So they have their very specific needs. They might have different restrictions based on the working context they're in or their own personal abilities, which also means we need tailored interfaces. In the engineering of such assistive functionalities, what is done at the moment, a lot of them are just developed from scratch without the ability to reuse some of the functionality. And MDE gives a great opportunity to allow for more reuse of such systems. Now, the research goal I have with the work I'm presenting you today is to look into how we're able to improve the engineering of software with such assistive services. We will have a look into three different areas: the area of what is needed in the architecture, what models can be used for generating such systems, and what models are interesting then at runtime of such systems. If we start with the architecture, also some unpublished work I can present you now. We have analyzed different kinds of systems, so assistive systems as well as context-aware systems and model-based systems, identified a set of functional requirements from these systems, and identified 16 components which are interesting to provide in an assistive system to support this functionality. And these components can now be used either to analyze an existing system architecture and have a look if it already realizes everything that you need for such a model-based approach to provide assistance, or you can also use it to design a new one. If you look a little bit deeper into this 16 components, I will just give you a very fast run through the different areas. We have the monitoring and the pre-processing of the data, which is basically we're working with raw data, especially if we work with context information. We are storing that information via storage manager in our databases, where we also have model storage for the runtime models. We also have the ability to transform data into models, because if we compare then during runtime models our data that we capture about behavior with the runtime models, we need such components to be able to transform them. And the main components are then the model handler, which evaluates what current status we're in. We have a reasoning component, which finds out if a support is needed, and then what is the next step of a user that should be supported. And a support component where we fill this support information with additional information, which we can then present to the user via support devices by either providing information, but also providing services where the user then could be able to interact with the system itself. And if we're going more into very autonomous systems, or at least systems which are able to execute things, we also need execution components and the connection to the controllers of, for example, actuators. We need administration functionalities, and for sure, if we need context information, we will also need interfaces to third-party applications where we might get additional information for such an assistive system from. What we have done is we've created a prototype looking into the different concepts that we have in this reference architecture. We've taken a use case as a smart kitchen, where we want to support the cooking process in a first step. So you would have here some kind of recipe, you know it maybe from your daily life, where you have different ingredients that you use, and you have this step-by-step proposals on how you should follow such a recipe. Now, this could be transferred into an assistive system where you have an interface showing you such step-by-step information and guiding you through this process. Here you can see some prototype, how it could look like, where you have specific instructions for the users, you have navigation possibilities, and you could add additional information like audio guidance or descriptive pictures. In the architecture that we realized, that it's here only shown a part of it, we have different kinds of models which are used to realize it. In the generation of the application, we're working with the domain model for the data models and providing information for the backend of the application, like the data storage itself, as well as the communication interfaces between backend and frontend of the application. We also have models for the graphical user interfaces that we're working on. And when we're talking about runtime of these systems, we are working with context models, which basically give us concrete information about the context instances we're working on, and task models which describe which processes we want to support. The system itself started from reusing an already existing generator framework that we have used in several projects, which is able to create, based on a domain model, which is a class diagram, and some GUI models, and whole information system with the database, the backend and frontend of the application. And you can add handwritten code in this generation process, and also follow an iterative development approach where you can add further handwritten code and still regenerate the system if you're making changes to it. If we want to adapt such a generator framework, we have to make several adaptations to get to an assistive system. Basically, if we need runtime models on one of one of the parts we need is a runtime model. This will also mean that we need some architectural components in the system core, the ones which I've shown you before. But we also need other ways of visualization and interaction possibilities, which are interesting. And some of these concepts is where we are working on at the moment. Now, I've talked a lot about languages. What is behind the languages I'm working with? We use the Monte Carlo language workbench for the compositional design of such languages. So the GUI models are created from this GUI language, and the domain models are from the class diagram for analysis language. And they are known by the context language models that we have created. We were able to reuse, for example, some of the SE units within that language, but also had to create our own packages for it, which we especially needed for cooking. For example, like a piece of something or a spoon of something is not something which was already existing in the standardized SE units project. As well as articles which we use for the German explanations and also directions to give some guidance to the users if he should look right or left or in other areas. And additionally, we also have the task language, which are the two main languages during runtime of this assistive system. If we look a little bit into the models that we have, one of them is the domain model, which allows us to describe the context. Here we have ingredients, utensils, storages, and machines. And one of these areas which might be also very interesting is that the storages and machines are able to have a nested layout, where I can give you an example for that. So for example, if you have a fridge, which is a reference layout, which means it's a reference point which you need to provide the users when you're allowing them to navigate to this reference point in a room. And this fridge has two composite layouts, one for the door, one for an inner part, and they again have these different kinds of compartments. Now, by having this very detailed descriptions, you're able to navigate people to a certain place in this fridge, allowing them to take things they would need for the recipes. And we also have different types of functional components for utensils and machines. So they could be, for example, equipable, fillable with something, or you could also control machines in different kinds of modes and ranges. Now, if we define our models during runtime, we need in the context model then concrete instances. Here is an example for a machine. So you could have a plate, which is on the back left. So you also have some navigation information already in this. It is equipable, so we can put something on it. This is one of the functional components, and we can cook and fry with it. And it is controlled by a button, which also has a certain relative position, which is in this case the third from right, which allows us to provide this information and later on to the users. We can modify it, and taking this information about very concrete objects, we can move on to the task language. Now, the task language itself allows the sequential description of tasks, in this case, following the recipe. We have different types of tasks. We have, for example, finding tasks, in where we can find ingredients or utensils in certain storages. We can have placing tasks where we could place utensils onto a machine. We can have filling tasks, we can have setting tasks, which is used for operating machines. And we also have a concept which allows us to define just plain text if you have tasks which won't fit into this predefined structure. And how we use this then during runtime is we take the information that we have in a task language. Here we have, for example, the task find a fillable with 3 liters, which can cook. we look into the information that we have in a context language. For example, here we have something which is fillable with 5 liters that would fit into the information that we have given in the task language, and it can cook, so it fulfills the properties that we're looking for. The reasoning component identifies that it's here this specific pot. And in the support component, we then put these informations together. So we guide the user that he's able to find the pot in a certain place, which is here in the kitchen, and defines in what certain place he's able to find this pot, which is the first drawer from below in this case. And this also works for other kinds of interfaces, which means we are creating the texts which are shown in these interfaces based on the information that we have in the context model as well as in the task model during runtime. We add some pictures for these different objects, where to find them. We also have audio information and some navigation shown in the graphical interfaces. Now, coming to an end, there might be a lot of open questions. One of them is, how could we tailor such assistance now to specific needs? Because we haven't seen what the different kinds of users which are in such a system are able to do. This is one of the areas we also want to do more research in future, but there are a lot of different areas where it's also interesting. So I hope I've shown you a short overview of what we're doing here in the area of architectures for assistive services, what models could be used for generation, but also what models could be used during runtime. And I hope you're as challenged as me with the future open research topics, and I'm happy to discuss some of the ideas with you in the MDE network. Thank you very much.